In this video, I'll turn Jupiter into a star and see how it affects its largest moons, Io, Europa, Ganymede, and Callisto. What will happen to them? How will their climate, temperature, and surface conditions change? We'll find the answers to all these questions in the Universe Sandbox simulator. Let's go! And I'll start by turning Jupiter into a star. As a star, it'll be the lightest possible red dwarf. Its mass will be 79 Jupiter masses. Why exactly 79? Let's find out. If in the simulator, let's say, we set Jupiter's mass to 78 masses, it shrinks like this. And look, it starts to heat up. It's heating up quite a bit, already over 1,000 degrees Celsius, but it's still a brown dwarf. And here you see it started to swallow its moons. Well, we'll deal with that later. But if we set the mass to 79 Jupiter masses, an important transition occurs. As you can see, in this case, Jupiter already becomes a real star, a red dwarf. It's with this Jupiter that will continue our experiment. And here you see that due to its increased mass, all its moons immediately began to be pulled in by this Jupiter and collide with it. I'll speed up time even more. There, Ganymede is gone, Callisto's gone, and the others will be pulled in just the same way. So we need to do things differently. I've restarted the simulation. Here we have Jupiter's main moons. I've removed the distant ones. Basically, they're not interesting to us. The main thing is to find out what happens to its 4 main moons. Well, I left these closest ones and its rings. Now I'll stop time completely and set Jupiter's mass to 79 Jupiter masses right away. Yeah, it's become like this, but once I start the simulation, it'll turn into a star immediately. But I won't start the simulation yet. I need to select all these remaining moons. And if we show their orbits, you see they'll fly straight into the star because of the mass change. But by going into their properties, the motion tab, and clicking auto orbits, they end up like this. So I've made it so the moons stay in their orbits after Jupiter's mass changes. And now I'm starting the simulation. Oops, did you see how Jupiter just changed? It's become a star, but a very dim one. And by the way, it swallowed its rings. But for Jupiter to ignite, we need to fast forward time quite a bit, and only then will it become a full-fledged red dwarf. Well, that's how it works in the simulator, but while Jupiter is igniting there, let's look at the impact on its closest moons. Here's one of its closest moons. Nothing special is happening yet, but let me speed up time in the simulator by another 10 times. Oh, and it just fell apart. And let's look at the moon Amalthea. What's going on there? It's not being torn apart as quickly here, but if I speed up time more to 30 minutes per second, well, this object is holding on for now. And what's happening with Io in the meantime? Oh, and Io, it's been stretched out. The simulation's paused now. We can see that even liquid sulfur dioxide has formed on the surface. Let's start time. Io is being torn apart. It's so close to the newly formed star Jupiter that the gravity is so strong that it's still within the Roche limit, and Io is being torn to pieces. I'll speed up time more. It's shrinking, shrinking, and shrinking. Insane. Let's see, let's check its characteristics. Oh, is it not showing me anymore? Ah, here. The radius is 33 kilometers. That's all that's left of Io. Wow, look at that. Basically, even the simulator says it's now an asteroid orbiting Jupiter. Incredible. And basically, this is how it all looks if you look from a distance. Essentially, Jupiter will have a new ring system now. And what's going on with Europa in the meantime? On Europa, things look better. Jupiter's gravity stretches it, changing its shape. The temperature is rising quite a bit too. The average temperature is already minus 45 degrees, but at least Europa isn't tearing apart. Yeah, some particles are flying off of it. Most likely, the ice is melting, and the atmosphere is just escaping into space. If we focus on Europa, we see that its surface is actually starting to melt. And looking at it like this, you can clearly see how Europa has been flattened. Now you see Ganymede, it's also being seriously affected by the gravity of the new star. And I see the temperatures rising on it as well. And here you see Callisto. Callisto is also losing its matter into the atmosphere, most likely. And we can see in the background how Io is torn apart, and what a hot ring it has already formed around it. It's already minus 143 degrees on Callisto, and it's also slowly heating up and the surface is melting. Here I am near Jupiter again. We see a large ring like that, a thin one though, from Io, showing you Io once more. 33 kilometers in radius, but it's so red hot, though the temperature on it is slowly dropping right now. And here's Jupiter itself. As you can see, it's heating up very slowly. The temperature hasn't changed at all. Like I said, you have to speed up time significantly, but if you do that, the simulator might not handle the moon's orbits correctly. So I'll do something clever. I'll save the simulation, I'll name it, say, Jupiter, and save it. Now, I'll start a blank simulation and take that same Jupiter and place it randomly somewhere over there. And now I'll immediately give it a mass of 79 Jupiter masses. It shrank sharply and became them like this. And now I just need to speed up time quite a bit. Oh, it's starting to grow. Let's see, let me do it like this. It increased in size a bit, and now I'm speeding up time even more. And as you can see, the temperature has started to rise. We can turn off this flashlight. I'll speed up time some more. And there we go. And our Jupiter has heated up significantly into a red dwarf. And that's it. So the final temperature is 2,842 degrees Celsius, and its radius is 1.19 times the radius of Jupiter. But the luminosity is very tiny. It's only 1,000th of the sun's luminosity, so it's a very dim star. And now I need to save this Jupiter. I'll name it, for example, Jupiter star. And now I'm going back to that previous simulation I saved. And now I just need to replace this Jupiter with the saved one. Here are my objects, and here's the Jupiter that's already heated up. And this is how it all looks now. Let's check its habitable zone right away. Oh, what do we have here? Almost all the moons are in the black zone. Only Callisto fell into the initial red zone. Wow, look at that. Well, now these moons should start heating up rapidly. Let's see what's happening with Europa. The temperature in Europa has started to rise sharply at just 1 hour per second. I don't even know what will happen to it next, but let's speed up time. It's already 3 degrees Celsius. Focusing on Europa, 1 day is passing per second. It's already 26 degrees and rising higher and higher. And here we see the first liquid bodies of water appearing on it. These liquid bodies of water are getting larger and larger, and an atmosphere is slowly starting to form on Europa. But we're very close to the start. It's likely going to be a very hot world now. It's already over 100 degrees Celsius on Europa, and what a transformation it's undergoing. The surface is already glowing hot, and the atmosphere is getting denser and denser. Oh man, this is crazy what's happening. Oh, that's it, a thick atmosphere starting to cover Europa. Now you see Ganymede, 5 days per second are passing in the simulator now, and the temperature is almost 300 degrees on it. And we see the surface melting, with liquid water appearing there as well. And here we see how a dense atmosphere is starting to cover the surface of Ganymede. Let some time pass for the climate to stabilize on all these moons, and I'll show you the final result. Time has passed and the climate has stabilized everywhere. I removed the moons closest to Jupiter because they were slowing down the simulation. We don't really need them anyway. So let's start with Io. Io looks like this, with Jupiter very close by. And in the end, its radius is only 27 kilometers, so it's gotten even smaller. And the average temperature is 452 degrees Celsius. It's also tidally locked to Jupiter, meaning one side always faces it. This applies to all its other moons as well. And this is what Europa looks like, actively losing its matter. It's also tidally locked to Jupiter, and the day side, as you can see, is completely covered by these thick clouds. But the side facing away from Jupiter isn't covered by those clouds. You can see the surface, but it looks like ice there. Let's take a closer look. All focus in. And yes, as we can see, over here, I assume, it's very hot, while over here it's very cold. And there's this narrow terminator zone where liquid water exists. In the end, the average temperature on Europa is 282 degrees Celsius. And if you compare the temperatures, the peak on the day side is around 804 degrees Celsius, while the dark side is actually very cold. The temperature drops to minus 112 degrees in some places, but where we have liquid water, the temperature is actually quite normal. I'm finding spots where the temperature is below 100 degrees. The surface pressure on Europa is over 9 atmospheres, and the atmosphere is made entirely of water vapor. There's a lot of it, 4 times more than Earth's atmosphere. Now you see Ganymede. It's also heated up a lot and is losing its atmosphere. If we hide the atmosphere in clouds, we see this molten surface on the day side, which always faces Jupiter, while in the terminator zone we also see liquid water and frozen ice on the dark side. The average temperature is 267 degrees Celsius. The day side heats up to 765 degrees in places, while on the dark side the temperature can drop to minus 95 degrees. But in the terminator zone, the temperature is just right for maintaining liquid water. The pressure here is just under 10 atmospheres, and the composition has a lot of water vapor, 24 Earth atmospheres. And now you see Callisto. Callisto looks like Titan. Well, it really has a similar colored atmosphere, but it doesn't lose its matter, as you can see. Let's look under the clouds, and we see, well, a similar picture here. The lit side is red hot, and on the dark side, this is the situation. Ah, and there's even liquid sulfur dioxide here because of these red bodies of water. That's definitely sulfur dioxide. I don't see anything at the poles. So far, I'm most interested in Callisto's unique water. Its average temperature is 306 degrees. legs. And again, if you check the temperature, the lit side heats up to 652 degrees in places. And on the unlit side, by the way, it's not that bad. The temperature drops to a minimum of 17 degrees Celsius. Well, it's rising now, most likely some kind of seasonal temperature fluctuations on Callisto, and the pressure on the surface of Callisto is 10.5 atmospheres. In the end, it turns out that it's very hot in the native orbits of these moons. The problem here is only the distance to the star. So I decided to try moving all these moons into the habitable zone. Actually, you can already see the orbits of the moons in the green zone of the star Jupiter. And let's see how much this improves the situation on the moons. And in this simulation, I've already returned Io to its normal state. And we start with Io. The climate on all these moons has already stabilized. I fast forwarded time. In this simulation, all the moons will also be facing Jupiter with one side. So in any case, the star is close and they will all be tidally locked. And we see that the lit side looks like this. There is an atmosphere here. And in the Terminator zone, there's liquid sulfur dioxide, and the dark side is slightly lit by the sun from this side. Well, yeah, we still have the sun here. Don't forget, it's right there. Well, there's this strip where there's no light at all. Here's ice. Let's look closer. Hiding clouds and atmosphere. What's this green stuff? It's vegetation. Life on Io. Unbelievable. The first moon and life right away. And yeah, by the way, by moving these moons away from the star, they stop losing their matter, which is great. The average temperature on Io is minus 77 degrees Celsius. The pressure on Io, by the way, isn't very high, only 1700ths of an atmosphere. The atmosphere consists of sulfur dioxide, and there's only 700ths of an Earth atmosphere here. Now you see Europa, and on the lit side, there's a little bit of liquid water on it. But overall, it's like the frozen surface stayed the same as it was, although the lit side seems to have become more desert-like. It's no longer losing its matter. The average temperature here is very low, minus 99 degrees Celsius. The probability of life is very slim here. The simulator shows that there's a very thin atmosphere of water vapor here. And this is what Ganymede looks like. As we can see, a large ocean has formed on its lit side. There's land, and the dark part is frozen like this. Well, everything's as we're used to seeing in this moon system. The average temperature here is minus 30 degrees Celsius. The atmosphere also consists of water vapor. It's over 12 Earth atmospheres, and the chance of life here is 1.5%. Very low. The surface pressure is also very low, just 600ths of an atmosphere. And here's an unrecognizable Callisto. It's acquired a very dense atmosphere. The surface is invisible at all. I'll script the atmosphere and let's look at the surface. There's this big, vast continent here. It's located on the illuminated side. And here's this large Terminator zone, I guess. Everything's surrounded by liquid water. So a boundary separating this cold world on the dark side and this hot world on the lit side. And here we see something unclear, as if there's some other liquid, not water. It's kind of dark. The average temperature here is decent, 38 degrees Celsius. And as for Callisto's atmosphere, there's a lot of sulfur dioxide, 1.72 Earth atmospheres. There's carbon dioxide at 1.77 atmospheres, and water, which is the most, at 196 Earth atmospheres. Wow, that's incredible. And ammonia at 2 Earth atmospheres. Regarding the liquid in the ocean, I see there's no water here, but if you go lower, there's water in the mantle. There's a lot of water here, almost 24 Earth oceans, and it's likely a melted mantle or something. But for sure, guys, this place is water. Well, besides this water, there's liquid sulfur dioxide, liquid carbon dioxide, and even liquid ammonia. And I take it it's accumulated somewhere in this spot, because you see the liquid here is kind of dark. Atmospheric pressure on Callisto is 5.5 atmospheres, and the chance of life is almost 3%. By the way, the highest of all these moons? And what's happening with our solar system in general now that Jupiter's become a star? Well, as we can see, it destroyed the asteroid belt. It's gone. I only see 3 asteroids. How Saturn interacts with Jupiter here. And in general, the orbit looks like this. And here, by the way, I see where Ceres and the other asteroids are. Jupiter, it turns out, threw them out of the solar system. In my opinion, in the habitable zone, the moons turned out much more interesting, especially Io and Ganymede. If you like this video, give it a like and write a detailed comment. Thank you very much.